our speaker tonight is Mukund. Mukund came to Facebook about 6 months ago, 9 months ago. I don't know, make something up. From Amazon, and before that was at Microsoft, and before that did a PhD at University of Washington. So he's a longtime Seattle resident. He's going to be talking a bit about some of the stuff he works on up here on data at Facebook. So without further ado, Mukund. Hold it close to your mouth because it kind of goes in and out.
Thanks for coming. All right, closed. So as Ari mentioned, my name is Mukund, and I'm going to be talking about some of the stuff that. Sorry, even closer. Okay. All right. So I'm going to be talking about some of the stuff that, some of the work that's happening in Facebook in the structured data space. Basically, structured data kind of means different things to different people. So I'm not going to define it right now, and it'll kind of be clear what I mean by structured data as the talk goes on. What I do is what I'm going to do is I'm going to be talking about three broad areas. One is data curation and annotation, which will cover some of the tools and techniques that we use in order to gather the structured data. I'm going to be talking about some of the tools that are helpful in this process, and then finally I'll talk about some of the applications that make use of the structured data that we gather. Yes.
Will your slides be available to us in some way? Taking lots of notes.
Probably not. Probably not. Right, so the first part is I'm going to talk about data curation and annotation, which is essentially how do we gather the structured data. So most of you probably know that Facebook, we have this thing called the social graph, and there are nodes corresponding to people, and there are edges corresponding to the friend relationship between people. But that's just a small part of the Facebook graph. The Facebook graph has lots of other entities. There are entities corresponding to businesses and music bands and celebrities and books and movies. So all sorts of different entities, so non-people entities. And obviously, since you have non-people entities, you have different kinds of relationships as well. So the Facebook graph is really this kind of typed, structured graph where you have different kinds of nodes and different kinds of relationships. And tonight I'm going to be talking a little bit about the non-people part of the graph. Right. So this is an example of what I mean by a node in the graph which is not a person node. Right, so this is a node corresponding to a local business right here in Seattle. And just like people, businesses too interact with other people. Right, so in this particular case, this business can use posts and photographs to interact with people. And likewise, people can interact with this business by going to this business, by checking into the physical location corresponding to this business. And so, in a lot of ways, it behaves like like a person in the sense that there are interactions between this node and other nodes, but it's a distinct entity. Right. So here's another one. This is an event. So it's kind of like a business in the sense that there is a physical location attached to it, but on the other hand, it has a fixed duration. And again, people can interact with this by attending this event. So we have musical bands, and so we have musical bands and celebrities, and these kinds of nodes can interact with their fans by posting video clips, by posting songs, interesting information about the band, and there can be a whole community around this business. So people can comment on their post, and then they can interact with each other. You can see different parts of this of their page showing the social context around this page. So there's a big difference between a page about the Beatles on Facebook and a page about the Beatles on the web in general. Here social context is pretty much integrated into everything, every page on Facebook. So you can see my friends who like the Beatles. You can see other people who like comments. You can see the number of people who actually like it all across the site. So lots of social context information there. And TV shows. One of the things that I'd like to emphasize is that the social context is particularly important because this is what allows us to make a personalized social experience, right? So the whole point of Facebook is that it's incredibly it's incredibly personalized. Every action that you do is essentially driven by, like we make recommendations. Those recommendations are essentially a function of who you know and what they like. We show a bunch of information to you based on the social context and based on your past history. And that's essentially what differentiates a page about The Wire on Facebook versus a page on the web in general. Right? Now, of course, you can have similar kinds of pages off Facebook, and you can still interact with Facebook through the Facebook platform. So you have, for example, on the bottom right, you have the Facebook plugins, like the like button, for example. So you can have different entities represented both on Facebook and off Facebook. And one of the things that we actually do is we try and bring some order and some relationship to these entities, both on and off Facebook.
Why don't you try this one? Bring it closer to your mouth, even.
Okay. So, wow.
It's weird.
Okay. So you, all right.
Distract things.
Right. So you have these entities. These entities are not necessarily unique, right? So you have an entity, a node on the graph corresponding to the wire on Facebook. Likewise, you have a node on the graph corresponding to the wire, perhaps on IMDb, like this site, right? Now, both you can interact with other people, and you can interact with this entity both on and off Facebook. And ideally, what you want to do is you want to interact with this concept of the wire. You want to interact with the wire, not necessarily with the wire representation on Facebook or the wire representation on IMDb. However, one of the things is that the way that the graph is structured, since anybody can create a page, like for example, IMDb can go and create a page, what happens is that you have these different entities, and these different entities are completely unrelated nodes. Now, because these entities are completely unrelated nodes, what happens is that any social interaction that you have tends to be split across multiple nodes, right? So for example, it could be the case that a friend of yours actually likes The Wire, but he or she liked The Wire on IMDb or Rotten Tomatoes. So when you go to Facebook and when you view the page on Facebook, it's not necessarily clear that your friends actually interacted with this or like this particular page, or if it's a case of a restaurant, that they actually went to the restaurant or they enjoy the food. So, one of the things that my team does is that we try and generate this metadata which tells us that these nodes are essentially about the same concept, right? So what we want to do is it's not that we want to actually merge these nodes. We want IMDb node to be distinct from the Facebook node. It's just that we want to know that these nodes are about the same concept. And knowing that these nodes are about the same concept essentially means that we can combine, we can pool the social context regardless of where it actually occurs. So what that means is that when you actually take an action, that action is tied to you. It's not necessarily tied to the IMDb node or to IMDb. So for example, now if you go and watch or if you go and look at the page for The Wire on Rotten Tomatoes, all that information that's generated from you and from your friends is also available on Rotten Tomatoes. Yes?
I don't mean it to be a semantic question, but as you describe this, what does liking mean? In the sense, when I say that I like The Wire on IMDb, am I saying I like The Wire, or am I saying I like this page on IMDb?
Well, what we'd like it to mean is we'd like it to mean that you like The Wire, right? So the idea would be that, so for example, here's another example. So let's say that you like a particular song, right? So you're listening to Pandora, you say you like that particular song. Now that information is actually used in order to provide other songs that you might like. So now if you go to another website, let's say Last.fm, I'm not sure if they have Facebook integration, but assuming that they do, if you go to Last.fm, what you'd like is you'd like that personalization to follow you on Last.fm, right? And so in this particular case, it's the concept that you actually like, not necessarily the representation on that website. So one of the goals is to make sure that we work at the level of the concept, not necessarily the individual node levels, right? So what we're trying to do is we're trying to make sure that the user actions actually follow the user, regardless of which site that they actually wish to use. right? So we want to make sure that your data is available to you regardless of where you go, and that's what I mean, right? So we want to make sure that, when you're building a website, let's say, like if you're building Last.fm, we make sure that we give you disambiguated metadata so that you can deliver a rich experience to people who use your website, as long as you use the Facebook platform, of course. Yes?
Are you reading other cookies, or how are you getting that information?
Can you guys use mics for?
Are you reading cookies, or how are you showing the data that data?
So a lot of this stuff is done through the Open Graph, so we actually can connect the IMDb node with the Facebook node, and once we've actually connected that, the Facebook plugins will be able to show you the disambiguated context. Great. So here's an example of what I mean. So this is a page about Pulp Fiction, and this is a page on Facebook. Right? So if you look at the top right, you see a bunch of my friends actually like this particular page. Now, yes, and this is the same page on IMDb, and you can see, well, a similar set of friends. I have a lot of friends, so you can see a similar set of friends actually like the page on IMDb as well. Right? And the idea is that there should be a social context regardless of which node I visit. Because I am the same person and the entity is the same entity. So we want to make sure the social context is there regardless of which, sorry, please go on.
Oh, we have a mic over here, and then we'll go over there.
Wasn't the first example a community page, and this one's a specific?
It is a page on Facebook. Okay. So basically, what we want to do is we want to connect up pages on Facebook. So you're right. I mean, there is a distinction between a community page and a known page, and I don't want to get into the distinction right now. But the larger point is that there are pages on Facebook which correspond to entities, and we want to make sure that that connection that you have to those pages is reflected regardless of where you go.
And that connection is based on the string name of Pulp Fiction in this case?
It's not based only on the string name of Pulp Fiction. We actually go through a lot of work to try and figure out exactly what it is that you mean. Definitely when you look at things like movies and books and songs, the string names can be very misleading. There are bands called you really can't use just string names. So there's a bunch of signals that we use, including things like social context, to figure out if they actually mean the same, if they try and represent the same entity or not.
So I just wanted to be clear. So my understanding, if this is correct, is that what you're doing is when I plug the Facebook social plugin into my page, you guys are taking the responsibility of disambiguating.
That's exactly right.
So then am I correct that you guys are disambiguating from the second I put it on, or do you need like N thousand likes to get that?
I mean, it's not going to happen from the second that you put it on because it's an offline process. It actually takes some amount of information. The signals that actually go into this, there are a bunch of signals that go into this, and those signals take some time to gather. Like, for example, we'd like to find out the behavior of users who are actually interacting with that plugin. We'd have to connect that up to the page. So there are some other, it's not instant.
So I guess my question really is it based more on word vectors, or is it based more on your social graph?
It's based on both.
Okay. Fair.
So how do you actually make sure that there are like 1,000 users making like 1,000 pages for Pulp Fiction?
Actually, that happens quite a bit. There are lots of pages.
Do you do anything for it?
There is an effort to try and make sure that we link those pages together. So we want to make sure that if people express their interest in Pulp Fiction, people express their interest in different ways, right? There could be pages saying, I love Pulp Fiction. There could be pages saying, I hate Pulp Fiction. Like, Justin Bieber and Lady Gaga are incredibly popular on our website, as everywhere else too. And, there are quite literally hundreds of thousands of pages about Justin Bieber and Lady Gaga.
So you do a string matching and then try to attach them, or do you have underlying semantics for these pages?
I mean, there are a bunch of different signals that go into our canonicalization. String match is an important one. The kind of comments that people post is an important one. The kind of the information about the users who interact with those pages is one. So there are a bunch of different signals that go in, both social signals and other kinds of text signals.
So
All right, I'm going to cut this off because, I got a bunch of slides and some of them are very pretty and I want to make sure I show those things. Okay. Apparently not. Okay.
So what is the main functionality of the plugin then? Does it expect me to actually be logged in as a Facebook user?
Yeah.
Because when I go to IMDb, I'm generally not.
I mean, if you don't know who you are, we can't really personalize it, right? That's kind of the point of personalization. We got to know about you.
Right, so is the idea then all of the internet is basically an extension to Facebook?
Facebook is an addition to the internet. I mean, it's not like, it's a valuable addition. It's not like you wouldn't say that the whole internet is just an addition to Google. I mean, there are cookies on your computer and then they do track your searches. I mean, they are different applications and they serve different needs. Facebook is, you have to be logged in and authenticated for you to get the best experience out of Facebook. But that is true for any personalization. Right? I mean, it doesn't make sense to say that I want great recommendation from Amazon and then say that, hey, I'm an anonymous user. You can have no information about you. The reason, if you want personalization, you have to give up some information.
Yeah, no, I very much understand that. The question is, I'm now navigating to an IMDb site.
Right.
And it's not natural. Well, I don't naturally expect that to be pulling in Facebook
it's
information.
true, but the naturalness is kind of a fuzzy. Different people define it differently, and lots of people definitely are logged into IMDb. So, yeah, let's take this offline. Right, so this is the IMDb page. So definitely logged in there. Someone. Quite a few people actually, if you look at it. Yeah. So what's the point of this thing? Well, one of the things is that, having social context almost always seems to increase the engagement that the site sees, right? So for example, in this case, we ran this experiment. We were comparing providing this pooled context across multiple entities versus not. And one of the things that we saw was that the click-through rate for the like button went up dramatically. The number of likes that the site received went up dramatically. The amount of social context that we could provide when they actually visited went up dramatically, right? So, so when we look at these sites, you have this little pile of faces on the bottom. So previously we could show some faces only to about, 0.3% of the impressions. After pooling it, it went up to about 6%, so that's a 20x improvement. So that went up. So generally across the board, by doing this, we found that engagement went up dramatically, right? So this is great for the site itself, for IMDb, because you have a much more engaged user community. This is great for the users because now the information that you've provided on one site is available elsewhere, right? So you don't have to go and, so for example, if you're on Pandora, you don't have to like the song on Pandora and then like it again on Last.fm. You like it on Pandora and that's enough, That information is available to you. You shouldn't have to repeat yourself, right? And that's what this thing provides. And this is true, for other things as well. It's not just about entity disambiguation, but it's also true for things like advertising. And I think part of it is because, people perhaps don't want to be the first, or perhaps people trust it more when their friends do it, or perhaps people are curious about, their friends liked it, so maybe I should check it out. But regardless, the fact is that providing social context seems to help dramatically with engagement. So one of the things that the group that I'm part of does is we try and create this metadata which allows us to increase social context and increase engagement, right? So that was one project that we were working on. Here's another one. We're trying to generate data for places, right? So Facebook has a places product, so you can check into places on your phone. You can check into locations or to businesses or to events. And one of the things that we were trying to do is we were trying to generate information so that this check-in process is as painless as possible, right? So ideally, when you go to a business, you check in, the business should show up immediately. So it should be essentially one press on your phone, and you should be checked in. That's the best case, right? So for that to happen, you really need information about the place's location. You need good information about, for example, what the place name is. You want full, complete, spelled right. And if you're actually looking at it more from this check-in, but if you actually want things like, if you want users to be able to find it and discover the place, you want to find restaurants near me, for example, you want categorization information. Perhaps you'd even like hours of operation, so you can find coffee shops which are open at this time. So there's a whole bunch of information that you would like to generate so that you can generate a superior experience, both in terms of discovery of the place and in terms of interaction with the place, right? So we were going through this project, we were trying to generate this metadata about these places. And, so I was going to tell you a little bit about how we went about this process. But just to set the context, this is a page corresponding to a place, right? So you can see there's a bunch of information that we actually show. So we show that it's a local business. It's kind of, not enough information. Ideally, we'd like to say that this is a Vietnamese restaurant, right? We know that it's in Seattle, Washington. Again, probably not good enough because we'd like a precise street address. We'd like hours of operation. We'd like phone numbers, perhaps even the website. So we'd like a bunch more information than we currently have. But I want to talk about this process in which, I want to talk about the process that we use to actually augment the information that we have about this place. So that was the downside about this, right, about the information that we have. But let's look at some of the upsides. So I know that Andrea visited this place, and Andrea loved this place. That's Andrea right there. So that's great. So I know that I should check it out because she loved the place. I know that Ari visited the place as well. He's right here. A bunch of my friends have gone there, so it's kind of strange that I haven't been there. So I should check it out. Yeah. Yes?
As a user of this, sometimes I find myself doing just what you described.
Wait, hold on 1 second. Here you go.
As a user of this, I found myself wanting to do exactly the scenario you just described, but I find myself on the page for the restaurant rather than on this, and the bifurcation of this kind of data of recommendations seems isolated from what might be a singular page for that Long might put up create for itself on Facebook. Does your rationalization that you're contemplating look at unifying the various types of objects that Facebook itself is creating events, places, and pages?
I mean, yeah, unification sounds a little drastic, but definitely what we want to do is we want to make sure that if there's a relationship between different nodes, that relationship is explicitly called out.
Or if Long, in this case, could say, yeah, that place is me, and this is my page.
And actually, Long can do that. We have a process called claiming, where business owners can actually claim that page. So one of the things that they can actually do is they can, there's a process, I'm not quite sure. Thank you. There we go. If this was your business, there's a process that you can follow. If you click that button and you follow through, there is a process in which you can actually claim that place. There are some places that I know which have actually gone through that process, like Yellow Leaf Cupcakes. They've actually claimed their place, and they publish all sorts of cool information on their page.
Thank you.
Yes.
How did you go about creating the first set of businesses?
I'm going to talk about that. Yeah. So there's definitely some good stuff here. We know, so a lot of the social, the interactions comes free, right? So now we have to do the hard work, which is gather all the metadata.
Just want to ask that we can hold the questions till the end if that's at all possible, just so we can get through the presentation. I'm sure all your questions are awesome. So we definitely want to have time for them. Thanks.
So let's see. So gathering information, finding out a list of places, building a gazetteer, a whole bunch of things, right? So let's talk about that. So one of the, so if you're actually going to go and build out your own database, one of the first things that you'll do is you'll try and see if somebody else has done the hard work for you, right? So that's the first thing that we did too. So there's a bunch of places that you can try and get data from, right? Like Wikipedia, of course. And then the US Geological Survey. The US Census also releases some very interesting information. Seattle has got some great data out there. So they put out a list of transit stops and a whole bunch of really interesting information. So the city of Seattle has actually put out some really cool information. So there's a whole bunch of places that you can go and get data from, right? One of the problems is with a lot of these places, you don't have recent data. they have their own long-running, multi-year cycle for gathering data. Like, for example, the census, every 10 years. It's not quite the same cycle that we operate at. So we need a cycle for which we can get data much more quickly, right? Recently generated places. And often one of the problems is that a lot of these places, as you can see, they're governmental organizations, some of this information. Wikipedia certainly isn't, but a lot of the other places are governmental organizations. So what that means is you're not going to find the same information, let's say, in Indonesia, right? So there are some issues with localization. The other thing is that the data actually comes in completely different formats. Everybody has their own ontologies. People give you a different subset of the data. So combining the data becomes challenging, or translating the data into the representation that we need is also very challenging. And one of the biggest problems is that a lot of these places actually concentrate on what I think of as phone book-like places. I think a place with a phone number attached to it. Right? But then there are a whole bunch of social places that we would also like to have. Public basketball courts, bus stops, porta potties, whatever. A bunch of different. These are. Porta potties may not be a social place, but it's a non-phone book kind of place, right? So what we want to do is we want to make sure that we have information about these other things as well. These places that are being mostly ignored. For perhaps good reason, right? Most of these other places, they're trying to gather information about businesses. Businesses paid to be listed, whereas public tennis courts are now going to be paid to be listed, right? So we want to gather other bits of information as well about other kinds of places. So this kind of data is often missing, right? So that's one of the downsides about this particular technique. But it gets you off to a great start. So a good chunk of the places that you actually want to cover is actually covered by this and related kind of data sources. Going back to your earlier question about whether a place was claimed or not, when places are claimed, perhaps the most authoritative source of information is directly from the owner of the business, right? We can ask them, well, what's your phone number, or hours of operation, or categories, right? So there's a good bunch of objective information that they can actually fill in. There's definitely some subjective information that we'd like too, things like how good is this place? Is this place good for a romantic dinner or whatever? Those, the owners tend to be less, they're not quite as objective about their own business as we'd like, right? So that's kind of, so there's definitely some objective information that we can gather from from the owners themselves. One of the other problems is that, there's only a very, very small fraction of businesses that have actually been claimed. So if you guys actually have businesses, you should go and claim your page so we can get the data. And of course, one of the other issues is there are a lot of places like porta potties, which, presumably nobody owns. So.
Very quickly, I'm sorry, is there a concept of places that move? Like a food truck that goes around the city?
That's a great one. I actually saw a guy who's checked into a 747 from somewhere up. So that's like the extreme case. And we don't have one right now. We have a fixed lat and long, but it's an interesting question. So here's an example, of another kind of technique that we use. We can infer it from user behavior. So what I mean by user behavior is ambient user behavior. So users are going about their businesses, doing things that they like, hanging out on Facebook, chatting with their friends. And while they're doing stuff, we can, there are certain bits of information that emerge from aggregate user behavior, right? And so we'd like to infer as much as we possibly can from this kind of aggregate user behavior. So there are a whole bunch of products that Facebook has. Check-ins obviously is the most direct relationship. But there are things like questions and events and pages and likes and a bunch of different things. Then we can actually use this information to figure out information that we don't have. Here's an example. So you check into both these restaurants. Perhaps it tells you something about both of these different restaurants, right? Maybe it means that both of these things are vegetarian restaurants. So maybe you can infer that bit of information. So if enough people check into both of these restaurants, perhaps it means something that these restaurants are related in some way. Right? So that's one bit of information. Another bit of information that you might infer is that, perhaps a lot of people are checking into one place right around lunchtime, another place right around on Saturday in the morning. So it might tell you something about the business. So the temporal pattern of check-ins is particularly important, right? So, one of the examples that we were looking at recently is, at the University of Washington, we have a basketball stadium right next to the football stadium, right? And the stadiums are confusingly named. But if you look at the check-ins that happen in a football stadium, it tends to take place on, one specific day of the week, whereas the stuff that takes place in the basketball stadium tends to happen at a different time. So there's a lot of information that you can actually infer directly. I mean, so if you want to find out if these two places are the same or not, you can look at the differences in check-in patterns and say that these two places are not the same. Right? So there's a bunch of information that you can actually derive from ambient. So I think of this as ambient user activity in the sense that they're not explicitly going and saying that these two places are the same or not. So there's a whole bunch of information that you can derive from ambient user activity to improve the experience for all users. Here's a cool one. So we have this product called Questions, which is, you think that Questions has got nothing to do with places. But, people ask all sorts of interesting questions about local businesses. Who's your favorite doctor? Recommend a dentist for me. Or in this particular case, what's your favorite pizza place? So in this case, if you know that, 3 of them are pizza places, it's a reasonable guess that the other ones are also pizza places, right? And you can do this without having to resort to sophisticated NLP techniques. These are relatively simple techniques that you can apply, and you can get an incredible amount of mileage from these simple techniques. This is a cool one. I was talking earlier about getting information from external providers. So this particular stadium, actually I'm not sure which stadium this is, but so for this stadium we were, our external providers, we went to 2 external providers, and the 2 external providers gave us 2 different locations, and those are the 2 push pin, those are the 2 pins on top, right? And so this is the information that we get from our providers. This is stuff that we might actually pay money for, right? And now we look at the check-in patterns of the users, right? And so this, by the way, was 2 weeks after launch. So this is 2 weeks of data. And this is 2 weeks of a brand new product which hasn't even, reached critical mass. So it's 2 weeks of data. And if you look at the median of the check-ins, it's bang smack in the middle, right? So there are a lot of these situations where the information that you can get from aggregating large but noisy signals can be much better than the information that you can get from, perhaps even dedicated providers. So whenever possible, it definitely makes sense to use the so-called wisdom of crowds approach, if possible. And we do use it quite a bit, right? So this is, for example, one of the techniques that we use in order to clean up locations. So we start off with something. It's a good guess. It's not the end of the world. I mean, it's a little bit off. It's a starting point. And then we refine it as time goes on. So we have these periodic processes which take the information and then we constantly clean it up. And the idea is that, we're trying to get to this point where our data just gets better and better over time. Right? And so correspondingly, anybody who actually leverages the data that Facebook has in various forms, their data will also get, the information that they have access to will also get better and better with time. Right, so, I talked about 3 different techniques so far, but they seem to be very, very different techniques. And so one of the things that we do is we use machine learning to essentially combine information from different sources.
I have a quick question. So far you are combining or verifying information within the Facebook.
Correct.
You're trying to kind of verify the information from the full website.
So I guess what you're asking is, do we actually crawl external websites and get additional information from external websites? And the answer is yes, we do. So the other thing is that, combining information using machine learning, right? So we have a bunch of different information that we get from completely different sources. And at the end of the day, what we'd like to do is we'd like to extend this information as much as possible. And we want to make sure that we can combine this information in a sane way. Right, so what machine learning allows us to do is it allows us to combine this in a systematic way. So in this particular case, for example, we can use the data from the external providers and perhaps the crowdsourced data and the data from the owners as training labels. And we can use the user behavior as features, right? And then we can actually figure out how to weight different features relative to each other, right? One of the nice things about these algorithms is it often comes with confidence estimates that you can then use. So different applications can use different kinds of thresholds, right? So something that you're actually surfacing to users, you might want to have much higher confidence versus something that you're using in the back end for search. Perhaps you can actually use stuff even with much lower confidence, right? So the fact that it actually has confidences allows you to use it in a range of different applications and extends it as much as possible. But it's important to keep in mind that machine learning doesn't actually replace any of the other techniques, it just amplifies their effects. So what it allows you to do is it allows you to take some information that's perhaps heavily concentrated around the head and then push much more deeply and then actually get to parts of the tail as well, right? So for example, perhaps the model will tell you that if it has Vietnamese restaurant in its title, it's a Vietnamese restaurant. It's probably a good guess, but perhaps now you're looking for a place which is new, which doesn't really have that many check-ins, which you don't have that much information about, and this allows you to generalize to new places as well. But of course, it's an automated technique. Nothing is perfect, and there are biases in your data that are actually going to show up in the model as well. One of the issues that we've seen is that there are large categories which receive very, very few check-ins. There's very little user activity around a large class of categories, for example. Plumbers, right? People don't brag about checking into plumbers, right? So we don't have that many plumbers, for example. So we have to come up with alternate ways of figuring out whether somebody's a plumber or not. Figuring out whether a business is a plumber or not, right? So a lot of the stuff that happens on Facebook happens in a very iterative fashion, right? So we tend to move fast, I've been told. So we generate, so the idea is that we build out a solution, we see how it works. If there are problems with the solution, then we fix it. So that's essentially what happened when we built out the machine learned model for categories. The first version that we built, it was reasonable. There weren't that many categories, but we saw some issues with it. One of the issues was that skewed data sets was a huge problem. Like, for example, there's a big difference between plumbers and airports. People love to check in airports. They don't like to check in plumbers. So obviously models will be much more inclined to predict an airport than a plumber, perhaps. So definitely as the number of categories increases, the quality of the model sometimes degrades. So right now we have several thousand categories. So what that means is the original approach that we took, which is one of a multi-class classifier, was not really scaling. So what we did was we took all the data that we generated and we looked at the user interactions, and then we built a second model. The second model was something different. It was more of a ranking-based approach. And this one can actually scale up to orders of magnitude more categories. It has much better support for skewed data sets, generally better all around. And so is the second model, but what it meant was, the first model we put out in a bit of a hurry. The fact that we put out in a bit of a hurry, the fact that we put it out, hurry or otherwise, the fact that we put it out meant that users could start interacting with it earlier on. And so the issues in the model were incredibly obvious to us. So rather than spending a lot of time trying to come up with the optimal model, we put out a first version of the model quickly, we looked at the issues, then we put out the second version of the model. The nice thing about Facebook is that you get to ship on a very, very regular basis. You don't have to wait for a year if you miss the boat. The boats come along very frequently. So it's, we can work in a much more iterative fashion here, which helps very much in the data side of things. Right? So for example, if you want to find out the list of categories that a place might be, so you can come up with a ranking model which ranks all possible categories. Right. So we can get into the details offline if you want. All right. So one of the big strengths of Facebook is its incredible base of engaged users. Users historically have been very willing to invest in improving Facebook. A lot of the translation that happened on Facebook, a lot of the translation was done by users themselves. So we have this incredible community of engaged users, and we can actually ask for their help in cleaning up some of the data. One of the issues to keep in mind is that you can't ask any user any bit of information, right? It doesn't help me. It doesn't help if you ask me information about a place in Houston. The odds are I haven't been to Houston, and I wouldn't know about that restaurant, right? So if you're going to ask me information about a local business, you're much better off asking me about a local business in Seattle. If you're going to ask me information about a band, you're much better off asking me about information about a band that I listen to, right? It doesn't do me any good if you ask me about a book that I've never read, right? So you want to actually you want to use the information about the user that you do know to figure out what other bits of information you can ask the user. Otherwise, it's just a wasted opportunity, right? So crowdsourcing on the face of it sounds very, very simple. Just ask the users, but it's actually fairly sophisticated. You have to figure out, one, what's the value of the data? I mean, if you're asking users to do something, you're definitely taking up some of their time, and you need to be respectful of that. So you have to figure out what's the value of the data. So if you're very, very certain about something, there's no point asking the user about it, even if the user is an expert about it, right? Second thing is you want to make sure that the user is passionate about it, or the user likes it, or the user will actually feel interested in improving the quality of that page or that business, or So you want to make sure that you ask you want to make sure that you get the information from the right user. And so in this particular case, for example, this is what one of the site Ego Unit looks like. So this relies on the fact that I've actually been to the place relatively recently, and because I've been to the place relatively recently, it's appropriate to ask me for information about this particular place. Right? So this is another example of social context. Another way is if you actually see the user visit a particular page. If the user actually visits the page, then perhaps they're actually interested in it, regardless of whether whether they've checked into the place or not. Perhaps they're considering checking in. Perhaps they're considering going. So if they actually visit a page, it's also an indication that the user is interested in that particular concept or that particular restaurant or business. So it's also legitimate to ask that user about information about that page, about that business. So this is what it looks like.
You always show the edit button?
The edit button actually shows up for all non-owned pages at this point. It might actually show up for all owned pages too, but right now it shows up for all non-owned pages. Non-owned places. So this is it's a crazy looking graph. This is the graph of information that we are actually getting from users as time goes by. Now, one of the reasons why I kind of like this graph is because it's not smooth at all. And the reason why it's not smooth is because we're constantly trying a whole bunch of experiments. You try different wordings. You change the design a little bit. You try different experiments. You ask users different questions. You use different selection criteria for the users. And so depending on that, since we're running so many experiments, you do expect to see a lot of oscillation in this graph. But one of the nice things about this graph is you can actually see the slope increasing. And that's the goal. So the experiments, we run a bunch of experiments, and then we look at what works and go with that. Right. Okay, so so that was all about gathering data. So there's a whole bunch of techniques, and that's just a small piece of it, right? I mean, there's just so many bits of information. It's there are lots of people here who would be happy to talk to you about more of this stuff, but that's all I'm going to talk about for now. Another aspect of the whole data process is you need to be able to process it. You need infrastructure that allows you to process large volumes of data. Facebook, of course, generates incredible volumes of data. So we were, the total amount of user activity was maybe about 1.2 terabytes a day a few years ago, 2 years ago. And now it's about 90 terabytes a day. So that's about 70x increase in the last 2 years. So that's a major increase, right? So the number of users is going up, the amount that they engage with the site is going up. So when we're actually talking about analyzing user patterns, we're talking about analyzing incredibly large volumes of data, right? Now, if you want to make sure that you iterate quickly, you want to make sure that when I actually try an experiment on this thing, if I want to process it, if I want to find out, if I want to train a model on a large volume of data, I want to make sure that it actually takes place in a reasonable amount of time. Okay. So we have some infrastructure which is incredibly good, especially if you're coming from Microsoft. It's so much better. Which is incredibly good, built on top of Hive, which is it's an open source stack. I'm going to skip through some of these slides because we're running out of time, but feel free to talk about this stuff later on. And we also have custom tools built on top of Hive, which actually allows us, we were talking about a discovery problem with respect to external data, but you also often have discovery problems with respect to internal data, especially for large enough organizations. So one of the things that we did was we actually built a tool which allows you to find and explore data and find experts who know about this data and figure out the lineage of data very, very easily. Because this is a huge problem, right? Typically, most people who work with data, often know this. Somebody's built up a data set and you don't know how it's actually come, you don't know how to use it, you don't know what the assumptions are. And one of the nice things about tools like this is it actually allows you to very, very quickly figure out who to ask for if you don't know the information. It allows you to figure out the information by yourself quickly. Okay. All right. Right. So applications. Right. So we've got data. We've got some. We've processed a whole bunch of information, and we have generated models. And the question is, what do we do with this information? Right? The basic one, so some of the applications that use it are, search. For example, if you're going out, you want to find places near you, right? So this uses a whole bunch of information. It certainly uses things like your location. So you need location-based search. You have to find places which are near you. But you also need to find, you also need category-based search, right? You often are interested in things like coffee shops near me, right? So you have a bunch of implicit and explicit kind of searches. So when I say implicit, I mean you're not explicitly stating the business that you're interested in versus explicit. Perhaps you're more interested in a specific kind of business. So you have this whole spectrum. So you have this search requirement which is both location-based and which is based on perhaps text. And of course, the fact is that the quality of the data is evolving. So you want to make sure that any solution that you build can actually work well in spite of the fact that your data is sparse and potentially noisy. Right? And it of course has to be fast and high performant as well.
One quick question is that, so all the entities created before, in the data, they are available for search here, right?
Correct. So there are entities which are created. So you have a large users can actually create entities themselves. So like for example, if you're trying to check into a business, and this is part of the crowdsourcing, if you want to check into a business, one of the things that you can do is if you don't find the business, you can actually create the business, right? And if you create the business, this becomes a user-created place that gets added to the node, and then other users can search for it. There are some rules around that. We can get into those rules offline. But we want to make sure that just because a user creates it, there has to be sufficiently high quality. We have to be certain that it's a sufficiently high quality place before we actually expose it to other users. Right? So there are some other rules to make sure that enough number of users actually believe that this place. There are some things. All right. So places search, right? So so the first implementation again, going with this theme, which is everything in Facebook is iterative. So the first version that we actually built out was essentially an in-memory query with some extensions so that you could actually do text-based searches. Right? So that was version 1. It used various different signals, things like general popularity measures, like the number of people checking into a place or the number of people liking it. So broad popularity measures were used for ranking. Some amount of social context is also used for ranking. Like for example, if your friends checked into a place or if you checked into a place, it's obviously an important signal for you. So those were all factors that went into the ranking themselves. There are some issues with it. It indexes regions, not necessarily individual points. The text search capabilities are much more limited because you're typically searching within a particular region which is predetermined. So the text searches are somewhat limited. And definitely for large rural areas, perhaps it can be more of a problem. Right. So the next version of search was essentially try to remedy some of these problems. So this one is essentially based on a much more standard reverse index. And what it did was, so the previous one was essentially, it's a completely in-memory, essentially single system solution. This one was a document sharded, so you can actually expand to a much larger set of places. So right now, instead of actually using the quad tree to find nearby places, we were actually using a tile-based approach, which fits in more cleanly with the reverse index. It has a much larger set of ranking signals, and it has much better support for real-time updates, which is very important. Getting to your earlier point, which is if users create places, we want to make sure that those things show up on a regular basis. The full base index is created on, most standard search engines, you create the base index, and that's a well-understood problem. You do it relatively infrequently. In this particular case, you want to make sure that real-time updates, incremental updates, get propagated very, very quickly. So the infrastructure has support for that. Yes.
Using your earlier example, then, if you were to check in, and amongst the places that were close by was Cafe Flora,
right.
You aspire to say, well, since you have an interest in vegetarianism, and that you can associate that attribute with that place, would that bubble it up on the list? Is that the kind of thing you aspire to do?
It's definitely the kind of thing that we aspire towards. It's definitely important. You want to make sure that you have, you want to make sure that you generate relevant results for the user, right? And we'd like to use every possible signal that we can in order to make sure that that happens. So it's definitely stuff that we aspire towards. Yes. So this is kind of what our search architecture looks like. Oops. This is what our search architecture looks like. Those arrows should be reversed. So we have an offline process which generates the index. We also have real-time live updates. This index is distributed across multiple leaves. And you have different parts of the stack. Like for example, the query completer essentially is it's like this auto completer or type ahead. So what that means is you start typing the query, you don't have to type in the whole query because we can often figure out what you mean from a few characters, right? And of course, what you want is you want this completion to be contextually relevant, right? No point showing me steakhouses, right? Or you want this to be, context means both personal and location, right? You want to show me things which are around me if you're showing up a completer, right? The rewriter essentially it handles things like spelling variants, which is a polite term for misspellings. So it handles spelling variants, it handles things like stemming, query rewrites, so if you say cafe, perhaps you mean coffee shop, perhaps you don't. So you want alternate terms, you want synonyms, you want a bunch of different things, and that's taken care of by the query rewriter. The aggregator does a bunch of things, including ranking. It combines the results from multiple places. And I'm kind of going to skip through the rest of my slides, and I'm going to stop right there. But we can talk about, we can follow up on the questions if you want.
Thank you. That was great. Question about categories. I've seen hundreds of categories and lots of duplicity in the categories. What are your thoughts there? And does there need to be thousands of categories of pages?
Right. I think that is a fact of life. So definitely when you expose things, when you let users start entering information, different users view things in a very, very different way. And so there is some amount of duplication is a fact of life. The way that we kind of look at categories is that, again, there's a scale. With a lot of things, there's a scale. There's stuff that you actually show the users, and that you want a higher degree of vetting. There is stuff that happens and use the data silently in the background, like, for example, search, right? And so in that case, you can actually perhaps use stuff which is, things like duplication and stuff don't matter nearly as much when you put it in the back end.
And real quickly, in the user world, there's a concept of a current location ID. Does that not translate to the places world?
Come again? I'm sorry.
If you call like a users.getInfo or something, it'll return a current location ID of where that user lives. Right. Corresponds to a state, city, country.
Right.
the places world doesn't seem to have any identifiers.
I mean, we do associate a place with neighborhoods and cities and states, and we actually do that. So in a lot of these places, if you don't see that, it's often the case. The reason might be because our information is incomplete. We try and infer as much information as we possibly can. These kinds of things are important for us for search, for example. If you say you want to find coffee shops in Nadrona, we should know if a place is in Nadrona or not, right? So we want to associate this kind of location hierarchy with places. It's something that we're striving towards.
Thank you.
Right, over here.
So right now, I don't think so that Places API has something which I can see what are the most number of check-ins happening in my at my location or my neighborhood. So are you guys planning something out?
I mean,
because all I can see is where my friends checked in.
everything at Facebook is a work in progress. So I'm sure it'll happen at some point in time. Not sure when, but.
Okay, sure.
Right next.
My question was about offline data. If I was, say, Pizza Hut and I had a bunch of cell phone numbers, usernames, addresses, stuff like that.
Right.
Let's say I want to check that in with Facebook or retain that data and find something about my users. Do you guys have programs like that?
I'm not going near that one. There is user information that you have. I mean, so Facebook is very, very, very careful about user information. So if the user actually enters their cell phone number or something, we're very, very careful about that. We definitely encourage businesses to be very, very careful about that information too. You want to make sure that the user gives you some information, they understand that the information is being shared with other businesses. So the answer is it's complicated, and there is no one-size-fits-all kind of solution for these things.
Over here.
I have a question regarding to the user checking data. So I don't think there's currently a way you can authenticate the user's location. Like I can use API to check in a place while I'm in New York, whatever. So is there any way Facebook is handling this case, or this is not a problem?
I mean, the superficial answer is it's not a problem. The reason is that, it's information about you. It's information that, so if you, part of the reason why you want to check into a particular place is so that you can get personalized recommendations and information that's actually personalized to you. So when you actually inject noise into the system, what tends to happen is you tend to degrade your experience much more, and perhaps even your friends' experiences. Because everything at Facebook is social, it also, the corollary to that is that the effect is much more localized, right? So it affects you, it affects your friends, it affects your circle, much more so. So there's a reason for you to not do that. The incentives are for you to make sure that the information is correct.
So like my scenario is I want to So my scenario
Is okay, I own say I'm a shop owner, I want to give a free laptop for those guys checking in my place.
Right.
So 100 guys checking, and actually I realized 50 of them are from the other state. So how do we solve this problem?
I'm going to take a pass on that one. I'll put you in touch with somebody who actually knows a lot more about that than I do, about trying to combat fraud. The answer right now is I believe the API lets you check in regardless. There might be some other safeguards to prevent these kinds of things from happening. All right. Excellent. Thank you. So as Ari points out, if you're actually, for most of the deals, you actually need to physically be at the shop in order to redeem the deals.
I'm a bit disappointed actually that we couldn't get to the recommendation bit, because that's really interests me. But anyway,
but we can talk about it later.
That's great. Yeah, my question is actually about recommendation. On those pages, not just places where you display the recommendation, the similarity, the things that are similar to the page that you visit.
Mm-hmm.
I wonder how much this comes from the wisdom of the whole crowd, that interacted with that specific page, and how much comes from your smaller networks of friends.
The answer is both.
It's both.
It's both.
Okay.
Definitely.
So, and how much is static and how much is dynamic? Because I would imagine that the
ratios change with time because our models evolve. So even if I knew the answer, it probably would not be valid for much longer. lot of it actually, I mean, so a lot of this information is actually trained on data.
Mhm.
So the right mix varies with time. Yeah.
And then another question on the places. It seems to me that it's very easy to create a new place, but what about removing places because it's noise, because they go out of business or something?
Yeah, that's an excellent point. I mean, definitely what you want to do is there are two ways of actually looking at it. One is you want to make sure that you constantly prune the graph and make sure that it's constantly clean and the good stuff is there and the bad stuff gets thrown out. The other point of view is that it's not so important to prune the graph, but it's important to make sure that the right information gets surfaced to the user, right? So for example, if there is a node in the graph but nobody ever sees it, do you really care that the node is in the graph? And I mean, and we do care that the node is in the graph, but I think the primary thing is that we want to make sure that if the business goes out, if the business goes out of business, a lot of the popularity signals will sync for that business. And so as time goes by, the business will not show up in your search results, it won't show up in your check-ins. So there is this organic thing, which is even if we don't actually kill the business outright from our graph, it's less likely to show up.
Hi. So over here. So my question is, take the example you showed us. Based on where you are, it's easy enough to find the nearby drop-down list. For example, we can see event here and something happened over there. It's a drop-down list.
Yep.
It seems easy enough you interpret this onto a map. And on the other hand, I can see a map that have my friends recently checked in. Is there a reason that you don't combine these two together?
Yeah, like I said, everything in Facebook is a work in progress. So, check us out in a little bit.
So I guess like engineering problem?
I mean, somebody in Facebook, I'm sure, is working on this problem.
Okay.
With very high probability.
So there's this huge ocean and sea of data, and it's great that it's already structured, but there isn't a great, I think this data isn't available in terms of searching. I don't know what are the most popular places among my friends. And I'm wondering if there are future plans of having these structured data more available, or is it more expected by companies, other startups to build up their own ways of reaching to the structured data?
I mean, my understanding was that information was actually available through the API, but if it's not available through the API, I'm sure it will be shortly. That particular bit of information. As a user, I see. All users are like that. Yeah, I don't know. I mean, there are definitely services. I mean, it's not a complex engineering problem because this stuff is actually solved in house. But I think with Facebook, there are just so many problems that engineers could be working on that it's often the case that some of these things take time.
I want to ask about the query disambiguation.
Yeah.
So if you have a query such as, Seattle Best Coffee, in different cases that can mean, different things. So what is your approach on solving those problems?
I mean, so if you actually search for things like Seattle's Best Coffee, you're right, it could actually mean completely different things. And often it does mean completely different things depending on the location that you are actually in. Like, for example, if you're out of Seattle, Seattle's Best Coffee typically means that you are searching for a specific business. If you are in Seattle, perhaps it's more likely to mean that you're just interested in best coffee. And, this is one of the nice things because you actually are training based on data that the user behavior. It's often incredibly obvious from user behavior what the right answer is. It's definitely the case that, if you look at searches, there's a reason why searches are good because they're actually looking at user behavior. And same thing will be true here.
I guess my question was, do you use some sort of machine learning for the query disambiguation?
We use a variety of different techniques, and all the techniques that we're actually using are constantly changing. So yes.
So we're a startup in town that actually accesses a lot of Facebook's graph data, and we notice a lot of duplicates in certain things, right? Obviously. Now, my question really comes down to how do you guys think about discovered duplicates after the fact? Namely, a whole bunch of users were checking into 2 locations, or you have 2 canonical entities for something, and you later discover that they're basically the same thing.
Right.
Do you guys typically ever actually find a way to merge them,
Yes.
or not really?
No, yes, we do.
Okay, so you have platform abilities to say, hey, take all the attached metadata and port them over.
Absolutely. That's the guy who's actually working on it. So, be sure to chat with him when you're done.
Great.
Jeff, by the way, his name is.
So a lot of people have tried to do this, building the semantic web. People have tried to, get people to create, like ontologies and things like that. You seem to be coming at it from the other way. Do you all think that you're building a semantic web? And second of all, is this generic, or is this more places focused? All the concepts around
No,
places and
actually,
locations.
the reason why I picked places was because there's a fair amount of work that's going on in Seattle about places. But there's a whole bunch of work going on in all sorts of things. We're also trying to categorize pages. We're doing the same kind of thing for deduplication for pages. We're trying to build up the same kind of metadata, not just for places, but for pages and for other kinds of things as well. Places is just because I wanted to focus on something. With respect to building the semantic web, the semantic web is just such a fuzzy concept. I don't think anybody knows what the heck that means. The point is that we're building up metadata that supports specific use cases. Very, very concrete, specific use cases. It's not meant to be a broad, generic store of knowledge.
My question was about the canonization of your data. Like, for example, suppose you have a product on, Nordstrom.com, and, there's some other instance of that product on another website, etc. Is there a way for developers using the API to access whatever data you canonize out of that? And on the other hand, is there ways for developers to kind of plug in and kind of just like you're getting data from users on Facebook to kind of help provide data that these 2 items are the same item and referring to the same item?
Not at the moment, but we are absolutely interested in doing that at some point in time.
Excellent. That'd be great.
So the whole deduping thing seems really interesting, and I'm remembering somebody saying once at a WWW conference that anytime you create a new feature, you create spam. And I can imagine as a business owner, I'd have a very strong interest in having everything dedupe to me. If likes to anyone else then become likes to me. Is the spam problem something that you're thinking about up front as you're designing this, or is that something that, first get the thing up and running and then figure out how to fix the spam?
With Facebook, a lot of the things is that the first thing that you do is you don't solve a problem that you don't know exist already, right? So a lot of these things, as we build out this product, if we see it's getting abused, then we'll fix it. And there are easy ways to actually find out if it's going to be abused. If you actually try and if you do a land grab for somebody else's one, it's clear that you're abusing the system. And then there are procedures in place for that. And actually there might well be, but at this point I can't, I don't know of anything off the top of my head that any measures that we put in place to prevent this kind of spam. That's a very good point. A lot of these things, they do actually get manually reported. I think in one case actually recently, there was a whole bunch of mergers that took place, and then, some small, just the fact that there's just so much, there are so many events happening on Facebook that even if a small percentage of people report it, that's a significant volume for us. And so we notice these problems very, very early on. And when we notice them, we correct them very, very quickly.
All right, so I see that there is one thing that's kind of missing from the way we can search. You said that we can search by text, we can search by anything, but could we search by image? So I take an image of a logo, then we check into the place.
Maybe someday, not right now.
Here you go. Here's a notebook for you.
Yeah, hi. I want to just go back to the very beginning. You said that you're relying on users for input, right?
Right.
And the idea is the more input a user gives Facebook, the better the experience is for that user and all of his friends, right?
Absolutely.
Do you do anything to measure that? Part of the reason I'm asking is just my personal experiences and my Facebook experience is kind of dominated by the most idle of my friends, you know.
Sorry, can you expand on that? What do you mean by that?
Well, they're the ones who write the most, right? I mean, people have a lot of spare time, you know.
They spend a lot of time on Facebook, they generate a whole bunch of information, and then they are...
But there's a quality problem, right? I mean, you know, it's spam within the Facebook, spam among my friends, right?
I mean, so there is a team which actually tries very hard to make sure that you see information that you will like, right? And so, or information that... I mean, like for example, there are various measures to figure out which pieces of content you interact with frequently, which ones you don't, and the whole news feed is actually heavily personalized. We try and optimize it. We often get it wrong, but it will improve with time.
We're going to take 2 or 3 more questions.
So I know we skipped a lot of the data processing.
Oh, yes.
Right here. A lot of the data processing, and maybe this would have been in there. But I really like the example of certain people. They both check into Cafe Flora and a vegetarian restaurant, and you try to figure out that there's a similarity between those two restaurants. How do your tools help you notice that there's a pattern like that?
I mean, let's talk about this offline. You know, there's a whole bunch of stuff that we do.
Is your social graph weighted at all? Do you have like a hierarchy of types, or are you working on creating that, or does every node have its own?
I mean, when you say a hierarchy,
as important
as
any other.
some nodes are more important than other nodes. Is
Yeah.
that what you mean? I mean, some nodes are more. No. Everything is related to something else, yes. There is no type hierarchy.
So a bus stop is just as important as an athletics stadium.
I mean, so let's say, so there are ways of actually getting to that kind of type hierarchy. So when I say that we have typed nodes, like for example, a node could be of type business, right? You can actually annotate that node with additional metadata, and that metadata itself could have hierarchy. So our categories, for example, in fact, do have hierarchy. So for example, restaurants is a category, and then you can have Italian restaurants, type of that. And so those nodes, there is a hierarchy implicit in those nodes. But on the other hand, you know, we don't actually try and compare, for example, events with places. Those are completely different things, not comparable. But we can actually impose more of an ordering or a hierarchy for our categories, and we do that.
So our last question right here.
Actually, my question was sort of just answered. So
Okay, go ahead.
How does Facebook as an organization encourage this culture of experimentation?
You know, I think there are a number of ways in which it actually encourages experimentation. The most important thing that an organization has to do to encourage experimentation is to make sure that failures are not fatal, right? You know, so if people can try things, and if it works, great. If it doesn't work, try and figure out why it didn't work and improve it. If the organization, people have that mentality, they respect that, and they encourage that, that does more for experimentation than anything else. When everybody around you is actually experimenting, you know, you tend to get the bug. Add some more to that. I mean, Ari's been here for a long time. Perhaps he can talk a little.
I was distracted. How to encourage experimentation?
Yeah.
I mean, I think a lot of it's just about, one of the things we try to emphasize at the company is tolerance for making mistakes. So last night we had a hackathon. We were up here. I apologize if I'm a little tired. We were up here all night kind of working on random stuff. And the idea is that you want to encourage people to try things and create an environment where it's accepting if you do screw something up, and you also make it very easy to to find out if something is working, making it very easy to release a feature to a small fraction of a percent of users or something like that and collect data about it. Some of the tools Mukund was talking about, like HiPal, that help us very easily get data when we are releasing something. And then we can find out very quickly if it's a mistake or if it's something that's working. Does that make sense? So I just wanted to wrap this up. First of all, thanks Mukund for talking. I was very excited when Mukund volunteered to speak, because, first of all, because engineers tend to be very shy, so that it's good to have him talking, but also because I think this is an area, as I think your questions revealed, it's an area that has a lot of work to do. Like, I think there's a lot of really cool problems in here, and we're just starting to scratch the surface of them. And but there's like so many more things that we could be doing, and I think we wish we were doing them, and if we had more people, we would be doing them, hopefully. So, which of course leads me into the obligatory message that we are, of course, hiring up here. This is one of the areas that we work on in Seattle, but there's a number of other areas as well. There's a few, Kate and Andrea, and I don't see Lindsay. Oh, there she is. Lindsay are all on our recruiting team up here. They're happy to talk to you, or I'm all, everyone here who's wearing a Facebook shirt is a good person to talk to about that. And we'll stick around for, I think, probably a half hour, 45 minutes or so to answer more questions if you guys have them. I think we're going to start moving some of the chairs out of the way just to make space for talking, but don't take that as a sign that that we're trying to push you out. We're happy to have you stick around. And in addition to Mukund or myself, Jeff is another engineer. Do you want to stand up, Jeff? Jeff also works on, actually I don't work on this stuff. Jeff and Mukund both work on this stuff, so give them the hard questions.